Welcome to The Deep Dive, the show that dives headfirst into the most complex research and, well, pulls out the essential knowledge you need to be well-informed. Today, we are tackling a really critical intersection of modern technology and clinical medicine, the diagnosis of severe, complex allergies.
And this is an area where the stakes are, they're inherently high. We're talking about patients, often very young children, living with multiple sensitivities, severe, really confusing symptoms, and just the constant stress of potential life-threatening reactions.
Absolutely.
And when you have a patient profile like that, the standard diagnostic methods, the skin prick test or even basic single blood antibody test, they can quickly become inconclusive. You get this sort of diagnostic drift and prolonged anxiety for the family.
I can only imagine. You think about the patient who gets referred to a specialist. They might have chronic eczema, asthma, symptoms of hay fever, and they react unpredictably to 3 different foods. Trying to trace which symptoms map to which allergen and whether those reactions are primary or, cross reactions, it becomes almost impossible using those traditional methods.
It really does. You're trying to solve a puzzle where the initial tools are they're inadequate for the complexity of the task.
Right.
And this is where the speed and accuracy of the decision-making process are just paramount. Clinicians need to make these high-stakes choices. Do we place this child on a permanent, really restrictive diet? Do we recommend expensive multi-year immunotherapy? These decisions demand swift, precise, and comprehensive data, which the older generation of tests often just cannot provide.
So the solution we're zeroing in on today is a genuine piece of cutting-edge technology. It's designed specifically to manage this kind of diagnostic complexity. It's called the ImmunoCAP ISAC 112, a molecular multiplex test. And it promises to map a patient's entire allergy landscape in one single go.
It does. And our sources for this deep dive give us a truly rich, multifaceted look at the reality of this technology, moving well beyond any of the marketing hype. We have a real-world UK clinical audit showing precisely how tertiary specialists are actually deploying ISAC today. We also have a systematic review that challenges its diagnostic accuracy against the gold standard and detailed analyses comparing it to those essential but flawed traditional methods like the skin prick test or SPT.
So our mission for you, the learner, is to unpack the reality of ISAC usage in the clinic. We'll evaluate the significant evidence gaps that have been identified by regulatory bodies like the UK's NICE and ultimately determine the crucial question. Is this technology robust enough right now to replace those traditional tests, or is it destined to remain an expensive but, limited complement used only for the most complex cases? Let's begin this deep dive. Okay, so let's start with the sheer technology behind ImmunoCAP ISAC 112. The official description is, it's dense. It's a CE-marked, molecular, semi-quantitative immunosolid phase allergen chip. That's a real mouthful. Can you break down what this thing actually is and how it functions differently from, say, a standard blood test where you're just looking for IgE to peanut extract?
Yeah, that is a mouthful. A good way to think of it is like putting a highly specialized, miniaturized laboratory onto a single glass slide. Traditional tests, they use crude extracts, a bit of peanut flour, a bit of pollen, to see if the body reacts to the whole mix of proteins in there.
Right, the whole shebang.
The whole shebang. The ISAC platform, by contrast, is what we call component resolved diagnosis, or CRD. It uses specific purified single allergen molecules that are derived from the source. So the ISAC 112, it's capable of testing for IgE antibodies against 112 different molecular components. And these are derived from 51 distinct allergen sources, and it does this all in parallel on that one single chip.
So wait, instead of one test for grass, you're getting individual tests for all the specific molecular components within that grass that might be causing a reaction, and it's all done at the same time. That's a huge increase in data density.
It is, and the technical benefits are just profound, especially in logistical terms. You mentioned the technical requirements. It needs only a tiny, minute sample, a single 30 microliter sample of serum, plasma, or even capillary blood.
30 microliters, that's nothing.
It's nothing. And the small sample size is transformative. If you consider pediatric settings, drawing a large venous blood sample from a highly allergic distressed toddler is a significant ordeal for the child, for the parents, for the staff. Being able to use a simple capillary prick, a finger stick, to get this comprehensive profile makes testing logistically easier and far, far less stressful. It enables testing in situations where it might have been postponed before.
And beyond the ease of sampling, the speed is pretty remarkable. Results are available in about 4 hours, is that right? That turns what could be a weeks-long multi-appointment diagnostic process into something that can potentially be managed in a single, rapid clinical visit.
Absolutely. But the conceptual shift is really the most important part here. We are moving beyond identifying individual sensitivities to determining a person's entire sensitization profile. This is invaluable for polysensitized patients, people who are reactive to multiple things, and it's absolutely key for decoding cross-reactions.
Okay, can you give me an example of that?
Sure. For instance, testing positive to the structural protein in birch pollen, which is called BET-V1, instantly explains why that same patient might react to apples, soy, and hazelnuts. It's because those foods contain highly similar BET-V1-like proteins. So you move from just treating symptoms to understanding the root molecular mechanism.
That comprehensive profile is what allows for truly personalized management. But despite this clear technological advantage, the path to routine adoption hasn't exactly been smooth, particularly here in the UK with NICE, the National Institute for Health and Care Excellence. What was their specific stance back in 2016?
Well, NICE reviewed the evidence base very thoroughly, and they concluded that, at that time, there was insufficient evidence to recommend the routine adoption of ISAC into the NHS. Their concern wasn't really about the technology's capability itself, but about critical gaps in the data regarding its measurable clinical utility.
Meaning, does it actually change patient outcomes for the better?
Exactly. Does it make a real difference? And crucially, its cost-effectiveness within a public health system.
So the tech was judged safe and effective in principle, but the data just wasn't there to justify the expense as a standard first-line tool.
Precisely. And this means its current use is highly restricted. The audit we reviewed confirms this. ISCA is currently used by only a small number of specialized tertiary allergy centers, and always on an ad hoc basis. It's reserved only for patients presenting with the most complex and confusing allergic diseases.
And that cautious approach is mirrored globally, too.
It is. The World Allergy Organization, or WAO, they treat molecular-based allergy diagnostics as a third-line approach. It's only deployed when the conventional initial steps, a detailed history, extract-based IgE tests, and skin prick tests, have failed to provide a conclusive answer.
That placement as a third-line measure makes the economic argument even trickier. Let's tackle that cost debate directly. The test itself is expensive. But advocates argue that its diagnostic power makes it cost-saving if it can replace a large battery of other sequential tests.
That is the core argument for ISAC adoption. And the greatest potential for cost saving lies in avoiding the oral food challenge, or OFC. We have to remind a listener that the OFC is the current gold standard, but it is enormously resource intensive. It requires a dedicated clinical setting, constant medical supervision, trained staff for hours on end.
And it carries the non-negligible risk of inducing severe anaphylaxis, which of course incurs further emergency costs.
A huge risk. So if ISAC can reliably predict the outcome of an OFC, or guide the decision to avoid it altogether, that is a huge clinical and economic win.
And do we have evidence that this cost saving is real in certain populations?
We do. There was one study looking at Finnish children which attributed a substantial cost saving of €480 per patient when ISAC was used. And this saving was largely achieved because the detailed ISAC findings led to clinicians feeling confident enough to remove unnecessary long-standing and restrictive dietary restrictions in a significant majority, 63% of the children tested.
Right. So avoiding that unnecessary long-term medical monitoring and dietary counseling contributes greatly to the financial efficiency.
It does. The cost of the test is offset by the cost avoidance of unnecessary long-term management and those resource-intensive challenges. It seems compelling.
It does seem compelling. So why then did NICE struggle so much with the economic evaluation?
This takes us back to the difficulty of creating a robust economic model. For NICE to recommend routine adoption, they needed key parameters that simply weren't available at the time of the review. Specifically, they lacked data on how often ISAC truly replaced existing tests versus how often it merely supplemented them. If 98% of patients are undergoing ISAC after already paying for multiple SPTs and single IgE tests, then the cost-saving argument diminishes pretty rapidly, because the ISAC cost is simply added on top of existing expenditure.
So determining its place in the clinical pathway. Is it a replacement or an expensive add-on that was the crucial missing piece needed for the financial justification?
Precisely. And until that clinical pathway usage is standardized and documented, the economic model remains uncertain, which, it explains NICE's necessary caution.
That question of replacement versus adjunct brings us directly into the real world. Our sources included a retrospective UK clinical audit, which looked at how clinicians in 2 tertiary clinics actually used ISAC on 100 patient cases, 50 pediatric and 50 adult. What did this real-world data immediately tell us about who gets this advanced test?
Well, it confirms that ISAC is overwhelmingly reserved for complexity, much as the WAO guidance suggests. We saw that 73.6% of the pediatric patients and 78% of the adult patients were specifically suspected of having multiple sensitizations. These were not patients with simple single allergy diagnoses. These were the patients whose history and initial tests had already stumped their primary care provider and often the secondary specialist as well.
So if I'm a clinician in one of these centers, what are the red flags on a patient's chart that lead me to pull the trigger and order an ISAC?
The clinical indications were really illuminating. In the pediatric group, atopic comorbidities, so multiple allergic diseases occurring at the same time, were the most common reason. Food allergies were cited in 62% of cases, but that was often alongside moderate to severe eczema, which was 40%, rhinoconjunctivitis at 28%, and asthma at 21%. The complexity was staggering. For some children, the request form listed up to 6 distinct indications for why the test was necessary.
6 simultaneous reasons. That really underscores the need for a tool that can untangle all those overlapping systems.
It really does. And for the adult patients, food allergies again dominated, listed in 82% of cases. But a critically important specific subset emerged. 18 cases involved reactions where clinicians specifically suspected pollen food syndrome, or PFS.
That's the cross-reaction between airborne allergens and plant-based foods.
Exactly. In the most complex adult case they documented, the clinician listed 11 separate indications for requesting the ISAC profile. These patients are often dealing with chronic, debilitating symptoms, and the need for precision is just urgent.
Okay, let's focus on the sequence of testing, because this directly addresses that economic uncertainty we just talked about. How did the clinicians integrate ISAC into their existing diagnostic flow? Was it ordered up front or later on?
We saw a clear divergence in practice between the two patient groups. For the pediatric pathway, ISAC was almost entirely an adjunct test, ordered after the initial assessment. A remarkable 98% of children had already undergone other investigations, typically skin prick tests and single-specific IgE blood testing, before the ISAC request.
So the consensus there seems to be exhaust the cheaper, less invasive methods first, and if the profile is still ambiguous or if the avoidance dye is overly restrictive, then you escalate to the molecular profile.
That's right. And significantly, the audit authors noted that no oral food challenges were performed before ISAC in any of the pediatric cases.
That is a critical finding.
It is. It suggests that for children, the primary clinical utility of ISAC is seen as mitigating the need for that risky, expensive OFC. The clinician uses the ISAC results to either confirm a safe reintroduction of food or to target the subsequent management plan. And in doing so, they leapfrog the necessity of the challenge itself.
Now, contrast that with the adult pathway. How different was the approach there?
Strikingly different. Adults were much more likely to have ISAC ordered early, with 40 out of 49 adults having the test requested at their very first appointment. And what's more, 15 adults in the audit had no investigations whatsoever prior to the ISAC testing.
Wow. That suggests the adult allergists are viewing it as a primary upfront screening tool, maybe a one-stop shop solution for rapid profiling. Why do you think that variance exists within the same specialized system?
Well, the audit authors offered a compelling analysis for that. They suggested that pediatric allergists often follow the disease progression chronologically. Allergies change and sometimes resolve in childhood, so that necessitates ongoing assessment. Therefore, ISAC gets introduced later when the diagnosis becomes intractable.
Okay.
Adult allergists, however, often receive patients who have been symptomatic and mismanaged for years, or whose disease is already stable but extremely complex. In these cases, the priority shifts to rapid comprehensive profiling to end that diagnostic odyssey quickly. So the overall data confirms that while ISAC can be used as an upfront tool in adult practice, its prevailing role, especially in pediatrics, remains that of an adjunct, a tool of last resort for complexity.
Let's pivot to the outcome. Did this expensive and comprehensive test actually lead to concrete, actionable changes in patient management?
It did. And often the action wasn't a radical change, but confirmation. In roughly half the cases, 42% of pediatric and 56% of adult cases, ISAC confirmed the clinician's initial clinical suspicion based on patient history and the prior tests. And that high specificity is incredibly valuable for just bolstering confidence in the diagnosis.
Confirmation is good for confidence, but what were some of the standout actions in the pediatric cases?
We saw several key outcomes there. In 11 pediatric cases, the ISAC results directly facilitated food challenges or guided a safe food reintroduction, which reduces the burden of unnecessary avoidance. 5 children were referred for specific allergen immunotherapy based on the component profile that ISAC provided.
And the power of component-resolved diagnosis was really on full display in the cases of new diagnoses, right?
Absolutely. The test led to entirely new diagnoses in 2 cases. In one instance, a child with presumed severe nut allergy was correctly re-diagnosed with a sesame allergy after the molecular profile showed component reactivity to sesame but not the major nut components. In the second case, a new pollen allergy diagnosis was added, which explained overlapping seasonal symptoms that had previously been attributed only to food. I mean, this is the definition of precision medicine, removing broad, unnecessary exclusions and targeting the actual culprit.
There was also a unique sort of non-biological finding about the utility of ISAC in the adult group. The audit noted that the test was ordered explicitly to reassure or convince the patient. How significant is this psychological utility?
It's profoundly important, and it's often overlooked in these regulatory evaluations. Patients with confusing, multiple diagnoses are often anxious, uncertain, and they may struggle with compliance. They've been told they're allergic to 10 different things based on, vague SPT results. When a specialist can present a detailed, objective molecular map, a printout showing exactly which purified proteins they react to, it provides a level of clarity and confidence that a simple SPT result just cannot match.
So the molecular data serves a therapeutic, non-biological purpose by reducing patient anxiety and securing better adherence to the management plan, particularly for those confused patients who are referred from general practice. That's a powerful clinical function in managing chronic health issues.
Okay, we have to move now to the most critical scientific question, which is diagnostic accuracy. If we're justifying ISAC's high cost by claiming it can help avoid the OFC, we must scrutinize the evidence that confirms it's an accurate proxy for the challenge outcome.
And again, the reference standard, the definitive diagnostic method, is the oral food challenge, specifically the DBP-CFC. As essential as it is, it comes with that risker profile we talked about, making molecular prediction highly desirable.
Precisely. So let's look at what the systematic reviews uncovered when they compared ISAC components directly against OFC outcomes. And the first massive hurdle is the gap in evidence coverage. The review found robust diagnostic test accuracy, or DTA, information available for ISAC components related to only 3 major allergies: cow's milk, BOS-D5, hen's egg, GAL-D1, and peanut, ARA-H1 and ARA-H2.
That's only 4 components out of the one hole on the chip. It means we are extrapolating the accuracy of the entire platform based on a very, very small sample of data points.
It certainly makes drawing definitive conclusions challenging. Let's start with hen's egg. For the major egg component, GAL-D1, the DTA results were reasonably homogeneous across different studies. The specificity was remarkably consistent and high, often ranging from 86.7% up to 97.0%.
High specificity means high confidence, right? If ISAC says you react to GAL-D1, you almost certainly failed the egg challenge.
Correct. The false positive rate is very low. Sensitivity, however, was more variable. It spanned from 57.8% to 84.0%. This means that while a positive result is reliable, a negative result is less definitive. It indicates that some people who failed the challenge were still missed by the GAL-D1 component test.
Okay. Now let's look at cow's milk, BOS-D5, which represents a structural protein. You noted the performance here was drastically different.
It was startlingly different, and this is a major area of concern. The diagnostic test accuracy was assessed using something called the area under the curve, or AUC. For BOS-D5, the AUCs were determined to be very modest, ranging only between 0.6 and 0.66. To give you some context, an AUC of 1.0 represents a perfect test, and an AUC of 0.5 is no better than a coin flip. A score around 0.6 is diagnostically very weak.
That is a terrible predictive score for such a high-tech test. What did this translate to in terms of sensitivity and specificity?
Well, the test maintained high specificity again, ranging from 93.7% to 95.7%, so positive results were still reliable. But the sensitivity was strikingly low. It was only from 23.9% to 40.0%.
Wait a minute. If the sensitivity is below 40%, that means the test failed to identify 2/3, maybe even 3/4 of the patients who were truly allergic and failed the oral challenge. That level of false negative reporting is a serious clinical liability.
It absolutely is. And it raises a vital question about how clinicians should interpret a negative BOS-D5 result. If a patient has a strong clinical history of milk allergy but tests negative for BOS-D5 on ISAC, the clinician must rely on the clinical history and disregard the negative ISAC result. They'd have to proceed directly to the OFC if required. The component test alone is just not reliable enough to rule out milk allergy.
Let's look at peanut, which is perhaps the highest stakes allergy and the most studied. What did we learn about ARA-H1 and ARA-H2?
The peanut components gave us clearer insights into the differential performance of components. ARA-H2 demonstrated superior and less variable diagnostic performance. The AUCs there ranged from 0.72 to 0.96. ARA-H was slightly less robust, with AUCs ranging from 0.68 to 0.91. This consistency suggests ARA-H2 is generally the superior predictor of a reaction upon oral challenge.
And why the difference in predictive power between ARA-H1 and ARA-H2? I mean, they're both major peanut allergens.
Right, they are. The difference often comes down to the biophysical properties of the proteins, which the source material touches upon. ARA-H2 is a highly stable protein. It's largely resistant to heat and digestion. This stability means it's more likely to reach the bloodstream intact, trigger a systemic reaction, and lead to severe symptoms. ARA-H1, while important, is slightly less stable. Therefore, detecting IgE to ARA-H2 is a far stronger predictor of a systemic reaction in a failed OFC than ARA-H1. This is component-resolved diagnosis at its best, using the test to predict not just if you're allergic, but how severely you are likely to react.
This analysis leads us to this consistent and rather paradoxical finding across all three food groups. ISAC components showed much higher specificity than sensitivity. Why does molecular testing exhibit this pattern, which is sort of the reverse of what we usually see in traditional screening tools?
This is a crucial concept, and it goes back to the difference between testing a component versus the whole food. Low sensitivity occurs when the patient is negative for the specific component measured by ISAC, say, ARA-H2 or BOS-D5, but is actually allergic to another minor or coexisting protein within the whole food, one that isn't represented on the 112 chip. That patient fails the OFC, resulting in a false negative for the component test, which drags the overall sensitivity score down.
So the test is fundamentally accurate for the molecule it measures, but that molecule doesn't always fully represent the total allergenicity of the food source for every single patient?
Exactly. And conversely, the high specificity is robustly maintained, because if you are positive for a major defined component, that reaction is highly unlikely to be an error. It strongly predicts reactivity to the entire food upon challenge. The pattern confirms ISAC's role as an excellent tool for confirming a suspected allergy, but a poor tool for ruling one out conclusively for certain foods.
Beyond the raw numbers, the systematic review also flagged major issues with the methodologies of the diagnostic accuracy studies themselves.
Yeah, this is perhaps as worrying as the low sensitivity scores. The reviewers noted that most DTA studies suffered from a high or unclear risk of bias. They identified several specific methodological flaws. For instance, a lack of blinding between the index test, the ISAC, and the reference test, the OFC, was common. If the clinician performing the OFC knows the patient's ISAC result, that knowledge can subconsciously influence the interpretation of ambiguous challenge symptoms.
And that introduces bias into the gold standard measurement itself, which just compromises the entire comparison. What about the cutoff thresholds?
Many studies were criticized for using unprespecified cutoff thresholds for the IgE levels. Ideally, you should set a threshold beforehand and test the population. If researchers choose the cutoff post-hoc, after looking at the data to find the level that gives the best accuracy, it artificially inflates the perceived performance of the test. It makes the published results look better than they would be in real-world clinical application.
So, given the limited data coverage and the quality control issues in the existing studies, what is the ultimate scientific verdict today?
The systematic review's firm conclusion was explicit. Due to limited, heterogeneous, and often poor quality evidence, ISAC should not currently be used as a replacement for the gold standard OFC. It is an extremely powerful, highly specific adjunct tool, but until we have robust, standardized DTA data covering more components and using rigorous methodologies, the oral food challenge remains the necessary final arbiter.
Okay, so if the evidence isn't there yet to replace the gold standard OFC, let's reframe the debate. Should ISAC replace the most common screening tool, the skin prick test, or SPT? One of our sources refers to the SPT as a historic compromise. What does that imply about its inherent limitations?
That phrase, it really highlights the fact that the SBT relies on the patient's own immune system and their skin as the testing surface. And this makes the test highly variable and dependent on all these external biological factors. We've been using a version of the SBT for over a century, and while it provides quick, highly sensitive information, it is fundamentally imprecise compared to objective laboratory measurement.
Let's detail those disadvantages. What are the key practical issues that ISAC fundamentally eliminates?
Well, first is the inherent imprecision and variability. SBT results are semi-quantitative, you're just measuring a wheel diameter, and that measurement is influenced by the skill of the staff member, the type of lancet used, and highly individualized patient factors. The patient's age, their BMI, the integrity of their skin barrier. A result of, say, 5 millimeters on one person may mean something completely different than on another person with, say, chronic eczema.
So the result is less of an absolute truth and more of a best estimate based on a variable biological reaction.
Precisely. And this variability leads directly to the second major issue, false positives, especially in patients with atopic skin conditions like severe eczema or dermatographism. Their skin is already highly reactive, making them prone to showing positive SBT results that don't correlate with actual clinical reactivity upon food ingestion. Clinicians then have to put these patients on unnecessary avoidance diets, leading to nutritional deficiencies and a reduced quality of life.
And we saw in that Finnish study how critical it was to remove those unnecessary dietary restrictions, and SBT false positives contribute directly to this problem.
They do. And third, the logistical nightmare of medication interference is a major practical limitation of SBT. To ensure the accuracy of the histamine-based reaction, patients taking common H1 blockers, tricyclic antidepressants, or other antihistamines have to discontinue these drugs for 1 to 3 weeks prior to the appointment.
Which is really difficult.
It's so difficult.
Yeah.
For a patient suffering from debilitating symptoms, forcing them to stop their medication is challenging, uncomfortable, and it complicates scheduling. IgE testing like ISAC completely eliminates this logistical barrier as blood IgE levels are unaffected by these medications.
And finally, there is the undeniable, though small, safety concern.
Yes. While the risk is low, systemic reactions, including anaphylaxis, can occur during SBTs. The range is reported to be between 0.0003% to 0.077% for major systemic reactions. This means SBTs have to be performed in a clinic that's equipped for immediate emergency intervention, which adds cost and complexity. ISAC, requiring only a small blood draw, is entirely free of this risk.
When you stack up all these disadvantages, the imprecision, false positives, medication interference, and the minor safety risk, the case for ISAC as a superior screening tool becomes really compelling. The proposed new pathway suggests moving from molecules to clinic, starting with a bottom-up molecular approach.
That is the argument, that IgE is the only reliable biomarker for type I allergy, and ISAC provides a standardized, objective reading that overcomes the variability of the skin. By starting with ISAC screening, the clinician gains that comprehensive sensitization profile immediately. This allows them to then perform fewer, highly targeted SBTs only to confirm clinically relevant findings, thereby reducing the number of skin pricks, reducing patient strain, and minimizing risk.
And which specific patient groups would benefit most from this upfront molecular screening?
The immediate benefits are clearest for the most difficult patients. First, the polysensitized patients, as we discussed, they need that full map. Second, small children who have limited skin area and are difficult to hold still for multiple pricks. Third, elderly patients where SBT reliability declines significantly after age 50. And critically, those patients whose skin health makes SBT unreliable, the ones with inflamed or severe atopic eczema. For these groups, ISAC is the superior starting point.
Let's look at a specific application where ISAC seems indispensable. Pollen food syndrome, or PFS.
Yes. PFS is a perfect example of why component-resolved diagnosis is necessary. It's a growing global challenge, with a prevalence estimated between 9.4% and 35% worldwide. And it's driven by cross-reactivity, for example, the BET-V1 protein in birch pollen, leading to oral symptoms when the patient eats an apple or a hazelnut. If you only test for the crude apple extract, you don't understand the underlying cross-reaction mechanism, which makes long-term management very difficult.
We have data comparing ISAC with another next-generation multiplex test, the ALX2, specifically in these PFS patients. What did this comparison reveal about ISAC's utility in this scenario?
Both systems proved invaluable. Multiplex testing fundamentally changes how PFS patients are profiled. The comparison confirmed that the measured specific IgE levels in both ISAC and ALATE2 significantly correlated with clinical symptoms for key allergens, such as MALD1, the major apple allergen, and GLI-M4, a major soy allergen.
And that correlation is the gold standard of clinical utility, right? It demonstrates that the molecular reading is a reliable predictor of the patient's real-world severity.
It is. And this supports genuine precision medicine. By having this molecular detail, clinicians can differentiate between a patient who might have a severe systemic reaction and one who just experiences mild oral itching. It's because they're sensitive only to the labile protein, like MALD1, which is easily degraded by cooking. This allows the clinician to narrow down the avoidance advice. Instead of telling the patient to avoid all apples, they can suggest avoiding raw apples but eating cooked apples, which minimizes the patient's burden from unnecessary dietary restrictions while maintaining safety.
To truly appreciate the power of component-resolved diagnosis and also its limitations, we should look at a really challenging case study, natural rubber latex, or NRL, allergy. This isn't just about food, it's about occupational exposure and surgical risk.
Right. NRL allergy is complex because it involves sensitization to numerous specific proteins, which are categorized as HEV-B1 through HEV-B13. Understanding which component the patient reacts to is essential for predicting the severity and type of risk.
And which of these critical components are included on the ISAC chip?
So the ISAC chip tests for specific IgE against 5 components: HEV-B1, HEV-B3, HEV-B5, HEV-B6.01, and HEV-B8. However, when ISAC was tested against traditional methods in a cohort of 40 patients with confirmed NRL allergy, a critical gap appeared regarding its sensitivity.
And how large was that gap?
In that specific study, where NRL allergy was confirmed by traditional methods like skin prick test, Western blot, and KAST, the ISAC sensitivity was found to be notably low at only 55%. This contrasted unfavorably with the conventional ImmunoCAP KD2 extract test, which achieved a sensitivity of 70%.
55% sensitivity means almost half of the truly allergic patients would have been missed by ISAC alone. That's a serious issue, especially when you consider the implications of a missed latex allergy in a healthcare worker or a patient who's about to undergo surgery.
This highlights the missing component issue in action. ISAC does not cover the full spectrum of known NRL allergens. It overlooks minor, but potentially clinically relevant, allergens such as HEV-B9 and HEV-B11. In that study, researchers confirmed this gap by demonstrating that using other singleplex component tests identified additional sensitizations that ISAC missed, including a case that was sensitized only to HEV-B9.
So the immediate key takeaway for clinicians is a negative ISAC result for latex must be treated with extreme caution and confirmed by other methods because the chip's coverage is incomplete.
That is the clinical imperative. However, paradoxically, despite this sensitivity limitation, ISAC shines at its ability to detect clinically irrelevant cross-reactivity, which is often the biggest source of patient confusion in latex allergy. And this utility is centered on the detection of HEV-B8.
HEV-B8 is a type of protein known as a profilin.
Correct. Profilins are ubiquitous pan-allergens. They are highly cross-reactive structural proteins found in numerous foods like banana, avocado, kiwi, and chestnut. This is the classic latex fruit syndrome.
So if a patient tests positive for HEV-B8, but they're negative for the other major components, what does that profile imply?
Monosensitization to HEV-B8 is widely considered to be clinically irrelevant to a genuine high-risk NRL allergy. Studies have shown that patients only sensitized to HEV-B8 typically do not experience pathological results when they undergo a simulated latex glove use test.
This is the expert insight that ISAC provides. The ability to distinguish between harmless cross-reactivity and a true systemic high-risk latex allergy driven by the major components, like HEV-B6.01 or HEV-B5.
That is the profound value. A crude extract test might come back positive for latex, which would terrify the patient and potentially lead to unnecessary job changes or avoidance of necessary medical procedures. ISAC isolates the profilin, the HEV-B8, from the true risk proteins. This ability allows the clinician to provide targeted, safe advice, and critically, to reassure the patient that their positive latex test is likely due to harmless cross-reactivity. It prevents so much unnecessary worry and intervention. It de-risks the diagnosis for a large subset of patients.
It's fascinating to realize that the most valuable clinical function of this cutting-edge test often lies not in confirming a risk, but in objectively confirming the absence of a genuine risk. #outro. We have covered a tremendous amount of ground today, dissecting the ImmunoCAP ISAC 112 from its molecular structure to its complex application in real-world clinics. We've seen that the current clinical reality is, well, it's full of promise, but also some very clear gaps.
Our key takeaways are clear. ISAC provides valuable, rapid, detailed sensitization profiles. This makes it indispensable for highly complex, polysensitized cases and for accurately defining pollen food syndrome. This detailed information supports personalized management and holds the substantial potential to help clinicians avoid the costs and risks associated with the oral food challenge.
However, we have to stress that the current data shows ISAC is overwhelmingly used as an adjunct, a complementary tool brought in when traditional methods fail. It is not yet validated or sensitive enough across the full spectrum of allergens, especially for high-risk allergies like milk or latex, to be a universal replacement for the gold standard OFC.
Ultimately, the test's greatest clinical value often lies in its high specificity. It confirms suspicion and, crucially, allows clinicians to rule out clinically irrelevant sensitizations, like that profile in cross-reactivity, which provides objective clarity, reduces patient anxiety, and guides incredibly precise management. It ensures patients only avoid the allergens that pose a genuine threat.
This technology is clearly where allergy diagnosis is heading, but this leads to our final provocative thought for you to consider as you wrap up this deep dive.
Given the increasing complexity of allergic disease, the necessity of decoding cross-reactivity, and the inherent practical limitations and imprecision of the 19th century skin prick test, the debate is no longer if we should transition to molecular diagnostics. The real challenge now lies in how we, as a global medical community, generate the high-quality, standardized, and unbiased evidence, such as through the creation of national unified registries recommended by the audit that is required to justify its cost-effectiveness, solidify its place in the clinical pathway, and ensure that ISAC becomes accessible and routine for all patients, not just those who can afford tertiary or private specialist care.